Oh, choice. Some people like that.
Power supposed to be posted.
Huh?
So the power supposed to be posted on it.
Yeah, I'll post them. I think they're all posted, aren't they? Maybe not yet.
So,
Okay, so just to review, we talked about photosynthesis. Talked about cellular respiration. What was the significance of that relative to fossil fuels that we're really kind of talking about now? Why is that important? Why did I go over this?
Well, fossil fuels made out of biomass, and that's usually what's in biomass.
Exactly. So photosynthesis is the process by which biomass is generated, and the only difference between living biomass that we eat in vegetables or burn in trees and coal or petroleum is that that was never burned or consumed, and it was basically put under heat and pressure and stayed in the earth. Recognize that in order for this to occur, you need oxygen. And anytime we use oxygen for a cellular process that uses that energy, we call that an aerobic process. And during that aerobic process, go back to your notes. What other it needs. So that's what goes in. What's one of the things that comes out? Carbon dioxide. So CO2 is generated, and therefore that goes out into the atmosphere, releasing that carbon that was bound up in those larger molecules that were made by photosynthesis. Okay, and we said organisms that undergo photosynthesis. Well, we had two categories of organisms. Autotrophs undergo photosynthesis. And all living things undergo cellular respiration. But heterotrophs only do what? Cellular respiration. Now, if you take a piece of plant, or you take some petroleum, or you take some coal, there is another way of releasing that carbon. So, you know, a coal furnace isn't a living organism, so it can't undergo cellular respiration. Or if you make a campfire and release the energy of that biomass, then that's a different process. And we call that combustion. It is also an aerobic process in that it uses oxygen. And basically you start with the fuel, which is either a hydrocarbon or wood. And in the presence of oxygen, it also produces carbon dioxide and also produces water. Typically that water comes off in the form of steam. So if you've ever made a campfire and you're burning some wood on that campfire, essentially what you're doing is you're adding oxygen to the fuel, and that fuel is then breaking down. You're taking those large carbon molecules with many, many carbons bound together, And by adding oxygen, the oxygen actually robs those carbon bonds of their electrons. And when the oxygen picks up those electrons, it then binds with hydrogen to make water. And as each bond gives up its electrons, it releases a carbon, which then usually there's a OH group here too. So it combines with some with oxygen to form the carbon dioxide. And notice it's basically the same process as cellular respiration. It's just that it happens very, very quickly. And the early people who studied metabolism, you know, how it is that living organisms use fuel, they basically called it a slow burning process. You're essentially doing the same thing, but you're taking those electrons and you're putting them to use to make ATP. There's no ATP being made when you burn a campfire. All that energy in those bonds is just released as light and heat. And combustion is the foundational process by which we use all of our fossil fuels. We burn coal, well, first we refine petroleum, then we burn it. Natural gas is burnt as well. And in every process, it requires the addition of oxygen and also produces carbon dioxide, which then goes back into the atmosphere from which it came. Now, if you're burning corn stalks, or if you're burning trees, that carbon came out of the atmosphere anywhere between 1 and, maybe 100 years ago at the most. But if you're burning coal, that carbon came in from the atmosphere 300 million years ago. So it's been out of circulation for that long. And you're putting it back into circulation at the point that you burn it. And from an environmental standpoint, that's one of the things that people are so concerned about, is what that carbon dioxide does when it gets into the atmosphere. And when we start talking pretty soon here about climate change, we will talk about that. Okay, any questions about this? Fundamental processes. You know what energy is. You know that undergoing these processes gives off energy. That's what we're after in doing this. You also know that every one of these processes is not 100% efficient, and therefore there's waste of energy, and that's naturally built into the system. Okay, one other thing I want to talk about before we turn on the projector. The way in which we use fossil fuels, regardless of which of the three there are, all fit into a procedure that people have to go through that's called an energy system. We talk about these sources as if, oh, you just go out, get some coal and burn it, and oh gosh, you're messing up the atmosphere. But there are companies that are doing this. There's people's jobs that are involved with doing these things. There's an economy around it, and it's not, the people who do this are engaged in a business, just like any business. And businesses can fail, and all businesses have risks that are associated with them. And this 5-step process now is part of how they do business. So there are 5 components to it. You can't just go drill a hole in the ground and say, okay, I'm going to go petroleum. Petroleum's not found everywhere. Coal's not found everywhere. Neither is natural gas. You have to actually go out and use some predictive methods for finding it. You have to undergo exploration. But you know, there's a whole branch of geology that focuses on determining where you find various fossil fuel deposits. Okay, and that's called exploration. All of these things take money. And that's money that has to be invested by the company that's doing the extraction and the processing. And there are various people, various organizations along the road that are investing in this. And ultimately, at the end of the day, they have to be profitable, otherwise they're not going to do it. So underlying all of these things is how much money is required and how much money is produced. And these are both dependent upon the price that you can get for that fuel. So right now, there are places around Hickory you can get gas for $3.17.9 is the lowest. Anybody have any lower gas prices? $3.17.9. Go to the Walmart up on 321 or the Raceway on 321. That's, I'm sure if you go to Rock Hill, you can get it cheaper because every time you go to South Carolina, the price drops like 50 cents to 75 cents a gallon. Okay, so when the price of whatever it is producing is fairly low, that's great for us. That's bad for the company. Okay, because they're making less on what they're selling, and therefore they have less money to invest back into that. We all complain when fuel prices go up, but that's great for the petroleum companies because they're making a lot of money when prices go up. Because now if they go up too high, people start cutting back on how much they buy, and then their profits are going to go down. So there's obviously a balancing act that has to occur there in setting those prices. But so first the resource has to be found. Once it's found, it has to be extracted. Okay, extraction is typically cheap in the beginning, but gets more and more expensive as you go. If I gave you a bag of black beans, and I threw in a bag of white rice, okay, and I said, okay, get all that white rice out of there, okay, and I mixed it up really well. At first, you'd look into the bag, and you could see the rice, and you'd be picking it out, and if you assume each grain of rice has a certain profit associated with it, you're making a lot of money because you're not spending much time looking for them. But what happens? As you keep picking them out, then they get more and more scarce, and you're spending more and more time looking for it, and therefore, at some point, the amount of energy that it takes for you to look for the rice is greater than the amount of energy you get from the rice. And at that point, you say, I'm done, I can't make money anymore, and I'm not going to do this. And you leave a certain amount of rice in the bag. Does that make sense? So actually, there's how much you can extract technically, and then there's how much you can extract practically. That's called the proven reserve. The amount you can extract to make a profit, those are different. You can extract a lot of oil, but you're going to be losing money. So why do that if you can't make money? So it's at this point that the economics of the situation is important. So various levels of extraction, particularly as it has to do with petroleum. Fracking has changed things a lot because we're able to get more out than we used to be able to get. It's generally never ready to use when you get it. Petroleum in particular, well, natural gas is pretty much ready to use, but coal typically has to be crushed and then dried and pulverized into a fine powder. Petroleum, you can't really use it. It comes out like a goopy tar-like substance, and you can't really do much with it. It has to be refined, and that's a very expensive process. Finally, you got to get it to where it needs to go. And then finally, there's what you're going to do with it. So for coal, the vast majority of coal is used for generating electricity. Petroleum products, everything from lubricating oil to kerosene to heating oil to gasoline, and even some methane that comes out of that process. So there's a lot that comes out of that. So that's called an energy system. So keep that in the back of your mind every time you're thinking about fossil fuels.
What's that bottom word?
End use.
End use.
End use.
What's that word up there next to profit?
Above,
To your right.
Generated.
Generated.
what?
Profit generated.
Is that what that is? Generated?
Yeah, profits generated. Yeah, thank you. I always have the neatest handwriting. Yes?
Can you say the definition for that proven reserve?
Yeah, it'll come up on the
Oh, okay.
slides. We'll get it. We'll see there. Okay. I put this slide in just to show you, to drive home the point that these are fossil fuels. The activities happen mostly during this geological time period. Okay, these years here refer to millions of years ago. Okay, so from 345 to 310. There's some fossil fuels that also come from this period. Paleozoic, Mesozoic, Cenozoic, we're up here right now. Okay, so this is a long, long time ago. The climate at that time, I mean, talk about global warming, it was really hot. And there was a lot of carbon dioxide in the atmosphere. And the world had many, many of what we called coal-forming swamps. Okay? So that period was called the Carboniferous because there was a lot of carbon deposits associated with it. Just to show you, this is time over here. So here we are right now, okay, and this is going back hundreds of millions of years. And this graph right here is the global temperature. So notice that relative to, there are a couple of periods in the past we were equally cool, but a lot of times it was really hot on the planet. So this is kind of puts the whole global warming thing into perspective, not that we should be going there, but notice that that's changed over time. What the important thing to see here is that during the Carboniferous over here, carbon dioxide levels were high, and therefore there was a lot of carbon that was being pumped into the vegetation that formed those coal swamps. Okay, so we've kind of just sort of gone over that already. The central case in your textbook has to do with tar sands. These are in Alberta and Saskatchewan, northern parts of Canada. The normal vegetation in that place is called a boreal forest. So you think of it as a lot of pine trees. They're mostly spruce trees. The only reason this is really becoming feasible is because it's becoming competitive price-wise. When petroleum was fairly cheap, this was economically infeasible. It simply cost too much to process this. These are deposits fairly close to the surface of sand and clay that's mixed in with petroleum products. And it's in there right now because it's a newsworthy topic. The Obama administration has had to make some judgments on this. First, it rejected it, now is leaning towards accepting it. And it's not, of course, it's happening in Canada. The extraction of it is going to occur no matter what. The question is how much of it is going to come to the United States. So here's some of the kind of key points. These are oil sands, and I just mentioned that. Bitumen is sort of a tarry-like substance. It's a type of petroleum. So the question that's raised, should we just keep going after more fossil fuels? Or should we sort of leave it in the ground, make the switch over to hydropower or nuclear or solar or wind? And could we feasibly do that? Lots of pollution resulting from that. A lot of environmental degradation, yeah.
So, like, what's your opinion on continuing fossil fuels or switching?
I don't think that we're going to be able to just move away from the fossil fuel industry, because what a lot of people don't realize is that all of our renewable energy sources are built on a fossil fuel infrastructure. So to make those gigantic wind turbines, well, that's aluminum and those all kinds of ores, and you're not going to build those wind turbines using just renewable resources. So I think we ultimately do need to start getting away from it, because all the evidence shows is that it's going to run out. At different times, probably the petroleum will run out first, and then the coal, there's more coal than we have. But eventually, it is going to run out, and we're going to be left in a world that, all of society the way we know it, we've all grown up in the fossil fuel era, and we take it for granted.
Do you have an idea when it may run out?
Yeah, there are lots of predictions on that. Coal, we probably have 200 years of coal left. Depends on how fast you use it. Petroleum, some people say we're already on the decline. And yet, people keep finding more, but they're finding it at greater expense. So some people say 25, 50 years of cheap stuff, and then it starts getting really expensive, and then you're going to run your car on coal. Some people think that, so now we're living in a pretty much global economy because transporting all the goods around the world is petroleum based. People think that at some point that might disintegrate and you're going to get local economies that pretty much are separated from the rest of the world, the way kind of it used to be. I mean, when we talked about the trade winds, that's how trade happened. You use the wind to get around. So now we're all spoiled on the fact that you can hop in a ship and go across the ocean or get in a jet plane. But it's all fossil fuel derived. So we're taking more and more petroleum out of the ground. The economy doesn't seem to be slowing down. The BRIC countries, Brazil, Russia, India, China, are all increasing their use of fossil fuels. So the rate at which fossil fuels are going to be used is increasing. So we're going to run out faster. Yeah, I think we do need to phase it out. I don't think we should just go gangbusters and just use it to every last drop, and then where are we? We have to be developing these renewable resources, because eventually it might be your kids experience this, or certainly your kids' kids. Probably, I might start to see things getting bad by the time I'm, ready to be pushing up daisies. Yeah.
Could it be possible for, say, a plank that you strap on, not strap, but work into the creation of the plane solar panels onto. So that way, since the plane usually hits at such an altitude, they would.
Onto a plane?
Yeah,
per
onto
se?
a plane. Just
Yeah,
to
they've
make
actually
direct
worked
sunlight.
that out. Trying to think of the name of the plane 2 years ago. A guy went around the world. It's called the Solar Glider, but you can't transport cargo. It's extremely, the balance between, unfortunately, solar energy doesn't have a high energy content. So, and this is one of the things that you have to sort of keep in mind. A chunk of coal has a lot of calories in it, whereas sunshine shining on a solar panel has much less energy on that square surface than you can get. And nuclear, forget it, nuclear is incredibly energy rich. You can get, and I'll give you the figures when we get to that to compare. I mean, that's the carrot, why we go for these things. So yeah, you can fly a plane on solar power. It has to be extremely efficiently designed, like an albatross. You know what an albatross is? Extremely large, long wingspan. It can be done. It runs a motor, but it's a real iffy thing. So to get to where we commercially are transporting people on those things,
You need to build up batteries for days before.
batteries, but then when you make batteries, how are you going to charge? You could charge them, and then there's the weight issues. So yeah, you get in a jet and you power up those big jet engines with good old jet fuel, which is fossil fuel. You get a lot of power out of that. So transportation would be very different. Here's just sort of the issue. So how's your geography?
Pretty good.
Where's the Canadian border?
Right above Minnesota, North Dakota,
Okay, right there.
stretching
So
across
there's
Montana.
the Canadian border. Here we have the United States. Here's the deposits that we're talking about. So mostly in Alberta. Here's the Rocky Mountains. So this is basically flat boreal forest. If you like moose and wolves and loons and the Great North Woods, that's it. So they got to strip all those trees off, and then they have to mine those. They have to mine those sands. Then they have to process them. They either take them out of the ground, and then they have to basically pour steam and really hot water over to separate the sand from the actual petroleum product, and then those are separated, and that's a lot of energy to do that. Which, if the price of the stuff doesn't support it, that whole process will shut down. So this is completely dependent. When I first started teaching this course, I talked about oil sands, but I said at this point it's not economically feasible because it just costs too much to do it. But the price of gasoline back then was much lower. Okay, so again, the distinction between economically feasible and technologically feasible. This is the existing pipeline. Once it's been separated, you're pumping that stuff down into the United States. This is the proposed Keystone XL pipeline that would make it quicker to get to market. What a lot of folks are concerned about is this area over here that's called the Ogallala Aquifer. An aquifer is basically ancient water that's down in among gravel and sand below the Earth's surface. And notice this area. This is kind of the breadbasket. This is big grazing land. This is short grass prairie. This is long grass prairie. A lot of that water is used for agriculture. It's extremely clean. It's been in the ground. It's been filtered through all the sediments before it finally gets into that aquifer. Aquifers recharge when it rains. Some of the water seeps down through there, and some of that water's been down there for tens, if not hundreds of thousands of years. Of course, before that, in the Mesozoic, this used to be an ocean with plesiosaurs and mosasaurs and all kinds of really great fossil deposits in these areas. So the concern is, as with most petroleum transportations, that there's going to be spills. And if you get a spill in this area, people are concerned about the aquifer, as they should be. Moreover, they're just concerned that we're doing it to begin with. But Canada's going to do it no matter what. It's producing a lot of jobs. And if we don't buy it, it's going to go to Vancouver, and the Chinese are going to buy it. So it's happening. unless some unknown thing happens. We have a huge petroleum boom going on in this country right now, right here, North Dakota. If you want to get a good job, learn how to work on an oil rig. You make $80,000 a year, pretty good for, it's hard work, but there's plenty of work in North Dakota if you move there right now. Now that's separate from what we're talking about here, but the economy is booming in North Dakota. This just happened over the last few years. Okay, here's some statistics. Homework assignment. I want you guys to come back on Tuesday. I want to know the amount petroleum produced per year by United States, Russia, Saudi Arabia, and Mexico, and also the world. The amount produced, and then I also want to know, so that's number one. So I want a number for each one of these. You'll probably have to do it in barrels. So I also want to know the number of gallons in 1 barrel of oil. Oil is generally measured in barrels. I can give you the numbers, but I want you to, it'll be more meaningful if you find it. 2 minutes on Google. Make sure you have a reliable source. So number one, I want the amount produced. Number two, amount consumed. Because I look at this and I say, 1.7 million barrels. Well, gosh, a million's a lot. But relative to world production, I don't know, maybe that's very little. Maybe that's a lot. So we'll need to put that in context. So this is pretty much already saying what I've said, except here that Canada has the 3rd largest proven oil reserves. And the USA is a major purchaser. And that's what this Keystone XL extension is all about. That dotted line is to make that easier to get it to market. There's 2 sides to every environmental topic. So the proponents say this is producing great jobs. You know, those are jobs that put people like you through college. Your dad could work on that, or your mom could work on that pipeline and put you through college. So this is not by any means a simple decision to make. Is that worth destroying boreal forests and all the other pollution that comes? There's a lot of water pollution associated with tar sands as well. People are very concerned about it. You get protests here in front of the White House with some nice wind turbines in the back. Okay, I think we've sort of talked about most of this, so I'm going to go through these slides fairly quickly. You sort of already know a lot of this. We talked about renewable and non-renewable resources. We definitely had a look at this slide. We also mentioned that a lot of this energy is used for generating electricity. You know, this is important. The reason that we do it is that these fuels have a high energy content. That makes it feasible. And they're also fairly easy, so it's easy to burn, it's easy to ship, and it's easy to store. That's not always the case for, say, natural gas. To ship natural gas, overseas in a tanker, you have to liquefy it. It's extremely dangerous and flammable. So some of these are easier than others. Certainly coal and petroleum, very easy to transport. Okay, and this graph just gives you a sense of what we're doing relative to time in the usage, consumption of all of these. They're all going up. As much as there's a push for renewables, I mean, those are going up too, but the fraction compared to these, you'll see what that is in a minute. This is important. Societies differ in how they use the energy. So typically, the world is divided into what's called the developing world on the one hand, and the developed world, and then a lot of countries that are sort of in transition that are going between those two. The developed world, this is the United States, Canada, Western Europe, Australia, uses this energy mostly for technology and for a lot of conveniences, whereas the developing world uses it very differently. So developing nations, so we're using it for agriculture, not so much for these are the poor countries. They're focusing on things that basically keep them alive. Agriculture, not so much for transportation, and transportation is often used, they use manual or animal energy, not fossil fuels. Industrialized nations, we're using it for technology. Look how much of the percentage of our total energy use is based on fossil fuels. So that's an important number for you to get down in your notes. 82% of our demand. Is supplied by fossil fuels. That is coming down ever so slowly. There really is a push for renewables. But they're just don't quite have the energy content. Okay, so this really kind of gives you the big picture. Let's take a minute to digest this. It's in your book. Obviously, you don't have to get it all down. But basically what we have here are the major sources. So here's petroleum, here's natural gas, here's coal. We'll talk about these later, nuclear and renewables. So you can see those are still a pretty small fraction. The renewables have increased. Okay, so this is the source of U.S. This is just the United States. Okay. That's the source of energy, and you can see how it's broken up. So transportation is taking about half of it, but also see that transportation is basically coming from petroleum, whereas coal is mostly going to the generation of electricity. Now you can use some, notice there's this little line coming from oil. You can just as easily generate electricity from petroleum, but that's not the way most of our power plants are set up. More natural gas. We've got a fair amount of natural gas electricity generating. Nuclear and renewables, a lot of that is going to electricity generation. Also notice that each one of these has this little brown bar, which is what? What law do you think about? Second law of thermodynamics, right there. That's why I said it. That's why we talked about it. Because just recognize that there's a total number of joules over here, and there's a total number of joules that are actually used to do the work, and there's always loss with each one of those. We can't escape the second law of thermodynamics. So, I don't know, it might be nice to put this up and maybe on a test, like maybe block out what these are, and then you have to fill them in. Then you'd actually have to kind of study this, but you know, just know most of the petroleum goes to transportation, most coal goes to generating electricity. Natural gas is being spread out pretty evenly, not a whole lot to transportation yet. Any questions about this? Production, consumption? A little easier to look at the numbers, I think. Okay. Okay, so just look at the top there. This is something that we're saying. So as far as the energy use, the developed world or the industrialized world is using 100 times more energy per person than developing nations. And based upon population, we only have 4.4% of the world's population, but we use almost 20% of the world's energy. So that tells you that per person, and me, myself, or any one of you is using a lot more energy. And that's because of what? What are you doing that a person in Mozambique is not doing?
Standard of living's higher.
Huh?
Standard of living's higher.
Meaning what? Like specific?
Everything, electronics,
Yeah.
heat, transportation.
You're driving around cars, they're walking. You are cooling your home, they're sweating it out. Pretty much anything you can look at. They probably have clothes, well, I don't know. They might have synthetics in their society, but you know, our clothes are processed petroleum. Essentially, everything we look at, our food is produced. When we talk about agriculture, you'll see how much agriculture uses in terms of fossil fuels. Our agricultural scene would change drastically if we didn't have fertilizers that came from fossil fuels, heavy machinery that's driven by fossil fuels. So much of our agriculture is petroleum driven. The regions that have reserves of fossil fuels are not spread evenly. So some places have a lot. The United States, Russia, China, parts of Australia have a lot of coal. Saudi Arabia, Russia, and now more and more the United States has a lot of petroleum. There are lots of countries that don't. This whole issue in the Ukraine, who's been following the Ukrainian issue, most of that boils down to energy. Because the Ukrainians aren't producing a whole lot of their energy, and they rely on Russia to get that. So in a lot of ways, and most of Europe is dependent upon Russia's oil reserves. The whole Crimean situation, Crimea, part of the Black Sea, has oil reserves in it. So you might say, oh, well, it's just a political push for territory. It's territory that's generating energy. So you can look at a lot of the major conflicts between Israel and Palestine. A lot of that comes down to water and good land for growing crops. Has to do with natural resources. Natural resources are at the foundation of a lot of international conflicts. They always have been. Okay, so half the world's proven reserves of crude oil lie in the Middle East. It's also rich in natural gas. Russia is really sort of coming out on top, not on top, but a major energy producer. And this just goes to show you how unevenly distributed. Now this is the consumption. This is on the consumption side of things. So notice consumption in the United States and Canada and Saudi Arabia, very rich lifestyles in Saudi Arabia. This is the energy consumption per person in metric tons of oil equivalent. So places that are using the least, Amazonia in South America, most of Africa, most of India and Pakistan, Mongolia, Central America. Although some of these countries are catching up. Okay, so this is something I've already started to highlight, that a company that is in the business of providing fossil fuels has to keep its eye on net energy. So the net energy is the amount that's returned, and subtracted from that is the amount that's invested. If the amount of energy returned is less than the amount invested, then you have a negative net energy return, and then you're not going to be in business. Okay? And in particular, EROI, which is the energy returned on investment, is a ratio. Okay, so you can look at any of the fuels, renewable or non-renewable, and calculate a ratio of how much energy is returned versus how much energy is invested. So this is a ratio. So if you're in the business of doing this, what do you want that number to be, big or small? Big. Okay, you want the numerator, the energy returned, to be larger than the energy invested. So let's take a look. Higher ratios mean we receive more money than we invest. And fossil fuels historically have had a high EROI. So let's see. Oil started at a 30-to-1 ratio. So energy returned was 30 units to every 1 unit that was invested. But notice that it's been coming down. So that was in the 1950s. Well, gosh, gas was 75 cents a gallon. It was so cheap back then. Today, it's dropped by 2/3. Okay, so it's 11-to-1. This is why the BP, well, it's not the exact reason, but this is why the BP oil spill, was that 4 years ago? 4 years ago? Yeah. That's one of the reasons it happened, because we're looking far into deeper and deeper waters to get the oil. Most offshore oil is in very shallow water. Might be just, 100 feet, pretty shallow. The BP oil was at 5,000 feet, so almost a mile down. Imagine using chopsticks to pick up a piece of chicken at a mile away. That's kind of what was happening. Imagine a mile of distance and you're drilling a mile below. So still very unproven technology to drill at such a depth, because we're going farther and farther. And that's why that ratio is what it is because it's much more expensive to drill at depth like that than it is on land or in shallower areas. Okay, let's just take a little break. 5 minutes, 3 minutes. Just stand up, stretch around a little bit. Get the mind rested. They say that when you're studying, if you get up about every 10 minutes or so, walk around, look around, play a little music, you're much more productive than if you just bear down for an hour. Some people can do it. Everybody needs a bathroom break? We'll start when you get back. Don't rush.
Just need some water.
Yeah. Okay, and then look at the energy return on investment for oil sands. They are much lower, so anywhere between 3-to-1 to 5-to-1, which, this is why those particular industries are so sensitive to the price at which they can sell these things. So when the price of petroleum goes up, those start becoming much more feasible. This is basically showing you that fossil fuels are getting more expensive. So this graph is a kind of larger frame, and then if we just look at 1950 to 2010, there's changes happening in fuel prices. Okay. Okay, so this is basically just saying that Yeah, so most of our advances in the 20th century came on cheap fuel. And as that fuel becomes more expensive and less accessible, you can also expect that this is going to ripple through society and make some drastic changes in how society functions. Okay. So we're going farther afield to find fossil fuels, and this is why the alternate energy sources, alternate strategies for finding fossil fuels to switch to clean. So the switch has sort of already begun. And what we really haven't talked about is the impact that these fuels have had on climate, which is a real grave concern. Okay, this is, we'll kind of get into the formation. We've already talked about this. Aerobic, when you either undergo combustion or cellular respiration, that requires oxygen. If you take oxygen out of the equation, we now call this